Welcome to a new test and teardown video. Look at this big thing. It is 15 kilos of metal. Of course it is one of these time writers, or it's a plotter, but it's also a volt and amp meter. It is Siemens Multizet type 26Z4-108. The internet knows absolutely nothing about this one. So I bet this type number up here is probably the voltmeter section or something like that. And then down here, this is probably the number for this unit, Multizet L11Z2-583. I don't know. The internet knows nothing. So please help me out if you know anything about this or know how to search the information. Multizet is repeated here again. There's a warning about high voltage, and it seems like this can do both amps and volts or whatever you're doing. 100 volts for the 30 amps. I don't know how to change this because it's just voltage input here. I don't know yet. This one is not 100% complete. As you can see here, there is actually another lid that goes over this, and this is why there's this locking mechanism that goes into that lid that is missing, and then you lock this and put in a padlock or something here, so you can avoid somebody touches anything. Probably the wires can come down here and something like that. There's also a way to put in some stuff here, so if this is opened, you'll be able to see somebody was in here. Look at that, huh? So if you open this, and we are in. Aha, I guess this is the on-off switch is hidden in here. Ooh, there's a funny smell in this machine. It looks like, I don't know. Okay, this is the zeroing of the meter. There's still this little, there's a little writer. Yeah, this is exactly how it works. Probably. So how is this working? Then it can go back. But it seems to be blocked from moving when this one is up. How the heck does that work? See? And then what? That doesn't work. Then it's gonna go all the way back and make a line. Aha, this is also what we see here. So it has been measuring something here and then oops, it makes a line back to 0 or something. I don't know exactly how to open this, but I see some stuff here. I can do something with this one. I can move the paper. What are they doing? I don't know yet. Ooh. Here you need some special tools to wind something. This one looks like you can grab it with your fingers. You can probably get this out somehow. I don't know. Look at that. So all this probably go like this, right? I just need to know how to unlock it somehow. I'll get back in a minute. I need to investigate a little bit more here. So I figured something out. This one can flippity flappity. If this is unlocked at both sides, and it locks here. So I guess this is the new clean, because it goes like 10, 11. No, does it maybe go this way? 6, 7, 8. So what is the direction of this? It moves this way, right? This is the way it moves. So this will be the old stuff, and if we unrolls this, yeah, we will see some measurements. And down here we can open this one, and then we'll see. Oh, you can take this entire reel up. Okay, so far so good. What did we learn from this? I still don't know how to. There's probably some sort of a little release somehow. It could be cool to see the entire mechanism. But I found. So this is the chassis. Have you seen a more sexy chassis screw? And look, it's all brass quality. But okay, it's 15 kilos, so yeah, that explains a little bit. So this is the back side. It says here you need to be careful. You have selected the right mains voltage, so you can move this switch here up and down. So that is really good. So how about I just power this up and see what happens. And again, I really hate it when there are some sort of screws or adjustments or something and no information. What is this? And then the same with that one. What happens here? Why have we two of them? What am I doing right now? Is that... Oops. Okay, let's just... Oh, did you see that? What happened here? Fuck me. The light went out, power is out. Damn it! So that thing is not working. I guess that was not the most intelligent move. Shit me. Oh, that was fun. I don't know. And this is exactly what happens if you don't do this. Ooh. There's a direct chassis connection. Look at that. From one of the pins here, and the other one 200 ohms. So that was probably the phase that I was connecting into chassis, and of course I am using a power cord with chassis, earth, ground, call it what you want, to this one, and that means my HPFI obviously protected everybody, and including me, from getting electrocuted. And there was probably a reason why this one was thrown out in the first place. So please, everybody, measure connections to chassis on both of your input pins when you're doing experiments on old junky things you find. Because there is a reason why somebody threw this out. I really need to figure out where is this problem with a direct connection from mains input to chassis, but those wires are really old and crusty, and they tied them really tight together. So this will be the input This is the mains fuse. So, okay, those are soft wires. I think I'm gonna see if there's a connector of some sort. Maybe I can unscrew this. I have no idea how to open this instrument. I got a lot of screws all the way around here, but this is not going to help me a lot, isn't it? I don't know. How do we get in there? Maybe this is a connector. Sometimes when I unscrew stuff here, I just hear a nut fall down and then nothing else is happening. But I got no idea how to open this thing. Man, I think I found the problem. Look at the crusty wires here. That is how crusty it is. So there's no... Oh, look at that. Oh, man. So this is why there is a chassis. This is... I can't remember I've seen anything this bad before. Oh my god, this is bad. This looks a little bit like some silicone wires. They're not so bad. But those... Look at that. It's just a lot of fun. Now I need to go and find a vacuum cleaner. Oh no! So... measurement input. That'll be the two left. This is the mains fuse. Is that one? Okay, and so that is the mains. I guess this is the hot one that goes to the fuse, or it doesn't matter in this connector, does it? So we got two wires. Oh yeah, okay. So we got two wires, and that will be the voltage selector. So when this is down, I think this is 220, and this is connected like this. So mains either come in one wire or in the other wire, I guess. I need to reroute everything here. So at least this video is going to document exactly how it is done. Oy, oy, oy. Now I need to open this a lot more. Of course, I tried to split all the wires like this, so now nothing is touching. And I was trying to ohm this one to chassis while doing this, and there's just a constant 0 ohm or close to 0 ohm connection. So this is not where the problem is, but of course we'll have more of these crusty wires inside as well. So how the hell do you open this? Now I can get it to move this much. I found 3 screws down there, and see, I got a very long screwdriver so I can get down there. And now I need to use this kind of tweezers to pick up the little mechanical thing down there. It's not that easy. I think I found it. So of course I shouldn't poke around with the screws down there. No. This screw. So of course you need to take out all the paper reels and whatnot. There is a secret screw down there. Yeah, but how the hell should I know? Now we're inside. That was super easy once you know what to do. But I must say I did not find... I did not expect to find all this. But this is... So there's another voltage selector inside as well. Really? And then of course these wires are super crusty. But what's that? Did you expect to find that? Yeah. So this is the, I mean, this is the meter, right? Oh man. And it's full of all sorts of mechanics. And what do we have down there? All sorts of other funny things. And so those spool gears you can unscrew and take out and change, and see inside the bottom of the case you find some more of them. I bet that is because you can make this unit work in 50 Hertz or in 60 Hertz land. Isn't that just smart? So the motor of course runs at different speeds, but then you can just change the gearing and then it's gonna go correct timing. I think we're gonna figure out exactly what is the problem here. We got all sorts of little fantastic thingies and a little amplifier, and what is inside this box is quite interesting. See, there's a glass lid. We got some all sorts of stuff. I think this is going to be a lot more interesting video than first anticipated. Now I am poking around a lot more. There was an on-off switch here at the front, remember? I showed this in the beginning. So that means this is of course for the motor. So you can turn on and off the motor, right? And now I've turned on the motor, and of course I can see this one is now shorted to chassis. And if I turn off the on-off switch, this one is not connected to chassis, but the connection from the input here is still connected to chassis. So what have we got here? This is the cable that goes all the way to that connector down here. So that will be the 5 wires, and I don't know exactly what's going on here because one goes that way, the other one goes that way, and those two here with the tube, they're directly connected to the input. So, and there are no short circuits here to chassis, so that's perfectly fine. And here we got the problem. Some of these are connected to chassis. So now I need to uncut all those wires, add some little labels on numbers and stuff, and to figure out exactly how everything is connected if I want to see if I can get this up and running. Meanwhile, I've been looking a little bit at the mechanics, and it is just absolutely beautiful. And I don't think those thick wires are in use, because you can see they end here and they end there, so they're not in use. But I think there's another winding on the meter that is connected to this thin wire. So obviously this meter can be in amp mode or in voltage mode, depending on how you use the whole mechanics. They didn't have two different versions of the meter itself. Also, what you see here is a really cool way to convert mechanical direction, right? So this one rotates, but this arm is connected here. So this is the end of the marker arm. So this one is moving like this, but you want it also to change its end, right? So the marker stays on a straight line. This they have done using all this mechanics. I hope I can show you guys this later when it's working. Also in this box I find something quite interesting. If I see, it says something about Schwingungskreis in German. So I think this has something to do with an oscillator or an amplifier or something. I think if I remove this tube, I will be able to read what is this box is about, but I think we should have a look, because I can see it's full of all sorts of stuff, capacitors and inductors and such. So what exactly have we got here? And some of those wires, they go all the way up here and they're connected to this, but maybe this is the power supply together with that one for the tube, or well, for the amplifier thing. Yeah, oh, the motor. So we got 2 windings on the motor, and that is because there was another internal setting for the motor. And this is of course a little bit stupid when there's a setting for mains voltage here. So this one connects the incoming phase to either this one or that one, and we have selected this one. But then again, we need to open the unit and change this. Isn't that a little bit funny? So it doesn't say something about something here. So it is an amplifier. And the 2000 ohms for the input, that is more or less what I measure here. So that input is correct. Maybe we can move the little wire here so we can see what this is all about, right? A klemme, T plus T. Okay, so there's probably some, yeah, see? T plus T, that will be T. Here, right? TT and EE, that is probably the input. Eingang, yeah, that is the input. Okay, so that is pretty good. Now we know a little bit more. But what exactly is inside this box, I really want to know. And also I need to cut away all the wires and stuff here. Oh, this is difficult to take pictures of. I'm sticking down my phone underneath the unit, and this is where the cable goes. And there's just no way I can get in here. How the heck am I going to fix this? But anyway, that's definitely why there is this shorted to chassis. Hey. I am about to get my breath back. I took out all the paper because I need to learn that I need to take out the entire unit from the case, and I wanted to figure out how can I do that. So I closed this lid and I took down those two, and when I did that one, I got the biggest shock in the universe. Can you imagine what this is? You need to have a special tool that connects here, and then you crank up or wind up. This system here contains a very strong and powerful spring and a gearing, and this is connected to the pickup reel that is mounted here. And when the reel is not mounted and I let this go, it just say whee, very, very, very loud, and spins around here like a crazy. And I was just about to fall down on the floor. Man. So how do I wind this up again? I got no clue. Maybe, okay. So this is maybe the, which way is the wind up or the wind down? Oh man. This goes really tight, but I have no clue of what I'm doing. So now I just did a tiny little wind this up by my fingers down here, and now I'm releasing the brake. Nothing happens. I thought it would be much more dramatic. I had the idea I could just wind it this way and then let it go. Whee! Boring. I mean, I'm not letting go this easy. Now I figured it out. It's not as loud as it was in the beginning. Of course, I only wounded it a little bit. But you can imagine there will be a huge spring here. And so why the hell isn't this shit mounted with a little arm on the motor? And what? This is just absolutely crazy. And I think the reason is you just need a little bit of pull on the receiver side paper, and it's moving really slow, like, I don't know, a few centimeters a week or a month or something like that. So it in reality it isn't really a problem. I think I got it. So that will be the locking of the hinges. Now I can get this thing out of here. I don't know, this is some crazy contraption. So this unit is just full of all sorts of stuff. I have no idea what is in here, but I think it is very interesting. I think this is the main meter, and the other one is acting as a servo or as a slave to this one. So this is the main, because look at that, we got a little adjustments thing here. Look at that, is connected to this meter, and when this meter moves up and down, it is connected to this coil and detection and amplification system, and it somehow drives the main one that is driving the readout. Wow, that is some fantastic way to do it. And what are all these components that I see in here? We are gonna go in here, and at the moment it is balancing on a screwdriver here, because I need to go and cut one wire at a time and mark them, so I now know exactly what is what here and then what is what here. Otherwise I'm never ever going to figure this out again. The only thing I so far know for sure, that will be these two inputs, they go to the amplifier. Okay, so that's fine, but these three, and then it's all the same black wires. It's amazing. But this design here isn't really the smartest in the world, isn't it? Oh, by the way, this on-off switch, isn't it just really cute? Boing. I like it. That is so cute. Completely open with mains voltage and all the good stuff on that one. Yep. This is how we do it. And metal is... Ooh, that is probably another one of the box. That one was right up the metal it was touching here. Hey-ya. Yeah. Ha! I bet I solved that problem. Well, and probably created a few new ones here. How am I going to get this cable holder thingy? And how did they... Aha! So when you want to service this you need to take off the switch, and then I'm not happy about that at all. Very complicated solution. If this was the dumbest or the smartest solution, but this was all I could come up with. See, I cut the wires at different length, from left to right, longer and longer wires. So that means I'll be able to figure out what is what. because right here they're going to be shorter and shorter, longer and longer, right? As far as I can see. But now I can take it out. You have no idea what I just discovered. All the screws for the cables here, they are just as loose as you can imagine. They're just falling apart. And you know why? Look at the cables, what they've done. They tinned the cables. Really? They tint them and then they stick them in and then they screw them tight. Oh man, that is the worst thing you can ever do. And they did this on both sides and on everything. And also here where all the wires come up in this unit up here, they did exactly the same. Oh, everybody knows this is completely forbidden. You can't do that. So here on the side, I removed the little protection plate. So this is the capacitor that is in parallel with the voltage winding. We got another transformator up here, that one. And again, we got different windings for different voltages. Isn't that something? Look at this. We've got 3 different coils. One is just the 0 coil. Well, this is just a spring, right? And the other 2, that will be voltage connections to the voltage winding of the meter that is down here. And like I said before, this meter is actually also a voltage current. I don't know if I can show you guys this. Yeah, here. The thick monster windings. And they are not connected in this unit. Here and here. We got the 2 halves of that, or the 2 ends of that winding. And that is because if you're using the current windings and the voltage winding, and you phase correct this with some inductors and stuff, then you have a watt meter. So this is what this is also possible to be used for, but they didn't do it. But because this is a very, very heavy expense when it comes to design, of course they just designed 1 meter that can do current, voltage, watts. That is really nice. I mean, the last hour I've been super frustrated about one thing, and that is this readout is completely locked because this one is lifted. Look, it is now lifted up here, so it is not touching the paper. And this arm that you see down here, I don't know if you can see it, it is the thinnest, most flimsy bimsy. It is not able to move this. It is really locked. If I push it up here, I need a lot of power to move it. So this thing needs to do this either constantly or with an interval or something needs to activate this thing. But there's absolutely no way this is possible because there's nothing at all connecting in either end. At least I can't find it. So where the hell is that? I've been looking everywhere for a mechanism that can do this, and it's just impossible to figure out. What have I not seen here? So I think I need to take away this scale to get in here to have a look, because if there's nothing that can touch or move this, or then nothing's gonna work. And by the way, I think I figured out how this works. I think you can take off this little top cap here, and then you can put in a little drop of paint, and that will slowly slide down here, and then there will be a little drop available at the end, and when it goes down and touches the paper, droop, you get a drop. Because there's no way you can take away this unit. This unit is like one piece, right? See? There's no way to take this out. Okay, I could pull it out. So still, this is our little paint. That's actually quite beautiful. But anyway, I'll save this for later. But it still doesn't solve this movement problem. It is completely locked here. See? Now we can move it. And then... Hey man, how does it work? This is all I care about. I want to figure this shit out. We got some magnets and stuff in there. That is really interesting. But I didn't really find what I came for. But I found something else. Look at the back side of the scale. It says Helmig. So that is a name. You see the 22 here. I also see 04, 53 and 108. But look here in the middle. I don't know if you can read this, but it says 1st April 1958. Can you see it in the middle? Yeah. 1958. Ain't that something, Helmig? Or Helmut? Oh yes, this is Helmut. Yeah. Yeah. I don't know exactly what name that is. Somebody at Siemens, for sure. Of course I found it! Yeah! I'm a genius, or I'm an idiot for wasting that much time figuring this out. Did you already figure this out? I hope you scrolled past all this annoyances. Hey, man! But here it is. Look at the lid. Look at that thingy. And you can loosen this screw and you can have it in on or in off. Duh. So you close the lid, and what is happening here is this thing is of course going here. Push this down and Bob is your uncle. End of that little annoying thing. I'm trying to put light inside this box so I can show you how this really works. So this is of course the amplifier for the input, but look what they're doing. To be able to drive this big instrument, you'll need quite a lot of power, right? So this is what you need the amplifier for. But look down in here. I don't know if you can see this, but this is actually also a meter, but with super high sensitivity. Okay? But look at what the arm is doing here. Can you see the arm goes to a... Okay, here we can see that. I don't know if we can show you guys this. But there's a tiny little metal plate. Yes, here we can see it, finally. Okay, so there's a little metal plate at the moment in between the two coils. So that those two coils, that will be the pickup coil. And up here is the sender. So this is the transmitter. This is where the signal is coming from, right? So depending on where this little piece of metal is, you get signal either in the left or in the right coil, or a variable amount of it. Can you see that? And this works by shorting the field via eddy currents that goes into this piece of metal. Phew! So this is how they made the amplifier in here. This is just amazing. So of course you can see the capacitors up here. This is a resonant circuit. I think this is super cool. I didn't really find the rectifier diodes and where is that? Because I can see the anode supply is supposed to be, see, it says here AA, that'll be those. So this will be the anode supply, this will be the heater supply for the tube. But that goes in here somewhere. But I can't seem to find that is not really easy to find. Oh, maybe it is in this one. Selenium discs inside this, and they mark this with plus. Oh, we have seen those before, right? It can also be in here, but this looks a little bit like an inductor as well. Probably inductor transformator for the oscillator circuits. Yes. I'm going to power this up now, by the way. Here is how I test the input. 50 millihertz and 10 millivolts peak in 50 ohms. And the signal generator is now connected to the input that goes directly to this coil. Let me see if I can get a... Why can't I get the better picture of the... Let me try this. Can you see the plate is moving? I think we can. Now it moves up. Look at that. So the primary side of the meter is definitely working. It goes up and down, and it is crazy sensitive in here. All I have to do now is power up everything and see if it works. So now it's going to be very interesting. What I have done here is I am trying to protect myself a little bit. So look at that. Chassis is ground. Okay, we got still, my signal is running in here. I expect to see some light in the tube, and I have unlocked. Okay, so this one can move freely. So let's just crank on. This is the motor. I don't think... Oh, that was not so good. Fuck a shock. Did you see the smoke and smash and what the not? Damn it. I was so sure this was all right. So after that little shock, apparently we still have let me see if I can get a good connection to the chassis. See? Chassis and mains. Ooh, not good enough. So this, not only did it take the HPFI protecting relay, but it also took my 10 amp fuse. Damn it. So there's definitely also a spark over here in this area. I saw flames and sparks flying out here, but I still got 0 ohm to 220 on this one. But I realized that the wires also goes here and to this switch. And remember, I already talked about this, and I already moved and pushed this one away, but apparently I didn't check it good enough. Look at that. So this is where the switch is, and this is where the screw is. So I bet there's a problem here. Did somebody fix this? Did somebody mount this the wrong way to get on and off the way they wanted it? Probably somebody wanted this on to be up instead of down. Maybe somebody moved this because, see, there's definitely not space for the switch up here, and they didn't see this. And also you can't access this screw, so this can't be original. So this switch must be the other way around for this to work. You gotta see this. Now I took away the on-off switch, and look at that. If I measure, let's see if I can measure this. See, now there's no more short to chassis. So somebody thought they were really geniuses when they screwed this up. Why do people modify stuff when they got absolutely no clue about what they're doing? That is a big mystery. And there's no way they could not have seen this, right? So this is the switch, and when you mount this, there's no way, you see, to mount the switch without hitting this screw. I think you can probably also see on the screw that it took some damage. And this is how you ruin a pretty nice and super sexy instrument with your modifications if you got no clue. Oh man. So this is going to be, what, the third time today? I think I fixed everything. The switch is now moved, motor is off. I'm going to blow the last fuse, I don't know. Let's turn it on. Ooh, 4 watts. Is it going to move? Of course we need the tube to be warm first. Yeah. Look. It was moving. Yeah. Yeah, it is moving. And then what? Are you not moving back? So where is the needle now? So my input is not... Yeah, okay, now it's moving back. Okay, it's my own fault. This is my input. So all I have to do is crank down the millivolts and crank down the... You see what I'm doing now. Let's crank up the frequency. Boing. It is very sensitive. So what is this? 2 millivolt, 3 millivolts. Okay, so we need more. 4 millivolts. Doing. This thing is so sensitive. It is really funny. But it really works. I'm running 100 millihertz of input signal, and there is obviously I need to phase, or I need to amplitude offset 1 millivolt DC, 2 millivolt DC, 3. I don't know, I need to play a little bit with this. It seems like it is very unlinear. So now I got a little, yeah, I need a lot less. It is very critical. But I think the amplifier is working. And that is exactly what I wanted. So I will call it a success so far. We got a lot of signal, and this fantastic amplifier system here is definitely working. Have we got a little bit of light? Let me turn off. Yes, we got a little bit of tube light. Filament is running. Of course, otherwise none of this would work. So, thank you for watching. Thank you for all the excitement. That was a lot of fun. Oh, should we turn on the motor? Yes, we should. And it is, of course, going. That is all we wanted to do. That is to play with the motor. So where is it? Is it going in here? Oh, yes, it is moving. It's moving all its gears and stuff. The wires are a little bit in the way. But anyway, the gears, they're gonna move really slowly, and Yeah, here we can see the arm is moving. That's really nice. Very, very complicated unit. Anyway, but I kind of like it. Let me see if we can. I think one of those days I'm going to figure out how to get some paint or some stuff in there and see if I can make some nice curves. It is using 10 watts at the moment, and if I turn off the motor, it is using 7 watts and 10. It's nice and quiet. One more detail, if you look up here, you'll see some copper pieces that is directly connected to the part that moves. And also remember, when I had this out, I showed you 3 big magnets up here. That is actually a damping mechanism. So when you're trying to move copper in a strong magnetic field, you're going to see resistance, and that is again due to the effect of inductance. So you're actually trying to induct voltages in the copper, and copper is a very good conductor, so that is why you're dampening the movements. So now I've been adjusting a little bit on the signal generator. I put in a series resistor, so now it was a lot easier to adjust the input voltage. And see, it runs actually quite smooth. And as you can hear, the motor is still running, and the motor creates tiny little amount of vibrations. Look what happens when I turn off the motor. Now look really careful on the needle when it's moving. I don't know if you can see. Yeah, you see? It goes not as smooth. Or is it because I'm moving it way too fast? This is, of course, not designed to move fast in any way. I'm just trying to see what it can do. See if I turn on the motor. But I'm super happy I managed to figure out what was to blame for the problem. That was not at all what I expected.